Hi everyone, this is F12A-Group2's team assignment presentation. I'm Qiaoshu Li, and today I will briefly walk you through the data preparation process. Before training the model, we first checked for any missing value in the dataset. As you can see from the output, only one column, arrival delay in minutes, had missing values. To handle this, we used median imputation. Since this column is numerical and might contain outliers, replacing missing values with the median is more robust choice compared to the mean. After imputation, we double-checked the dataset and confirmed that all missing values had been successfully filled. To address the imbalance between satisfied and unsatisfied passengers, we used undersampling. We randomly sampled the majority class to match the size of the minority class. This gave us a balanced dataset with equal representation from both classes. Undersampling helps reduce bias towards the dominant class and improves model fairness, especially for metrics like recall. And before we move down to model training, especially for the new neural network, we normalize the numerical data, use min-max scalar. Normalization is crucial for neural network because it ensures that different input features are on the same scale. We applied the scalar to the training site and then transformed the test site accordingly to ensure consistent scaling. As the final step of our data preparation, we performed a noise test to identify and eliminate any potentially irrelevant features. We first evaluated and selected the 5 least important variables. To test their impact, we removed these variables and retrained models. Then we compared the accuracy before and after. As shown in the result, the model performance stayed nearly the same. This suggests that the dropped variables had little to no impact on prediction performance. As a result, we decided not to run this noise test code, since removing them would not improve our model.
Exactly, after that, I will introduce some detail about our model building. To evaluate how well our models perform, we look at key metrics: accuracy, precision, recall, and F1 score. After completing the 3 required baseline models, we expanded our work by improving random forest, XGBoost, and building an ensemble model using Bolting classifier. We also use IPA clustering to explore patterns in the data from an unsupervised angle, helping us uncover insights beyond standard predictions. A big reason for our model improvements was a pre-processing pipeline we designed. This step made the data more consistent and easier for model to learn. We then used a cross-validation method such as grid search and random search to tune each model. For the decision tree, we tuned tree depth and split strategy. For the logistic regression, we tuned regularization stress C for both L1 and L2. For neural network, we built a 3-layer feed-forward structure with ReLU activation, trained using ADAM and early stopping, converged around epoch 13. For the random forest and XGBoost, we tuned key hyperparameters like number of trees, tree depth, learning rate, and subsampling rate to improve generalization. Here you can see the parameter of our models. After optimization, every model saw a clear improvement. We can see the logic regression, the accuracy improved from 78% to 87%. The decision tree, it improved from 80% to 95%. The neural network, it improved from 80% to 96%. Of course, the random forest and the XGBoost, it improved from 80% to 96%. To push our results even further, we built an ensemble model using soft voting. It combined logistic regression, random forest, and XGBoost. Each model was tuned separately before being added to the ensemble. The final result you can see up here, the accuracy from 96% to The accuracy is 96% and F1 score is 95%. This model combines strong performance with stability and explainability, making it our top recommendation for deployment. For business perspective, especially when predicting passenger satisfaction, false positives are riskier than false negatives. Why? Because when we wrongly assume someone is satisfied, we might ignore real compliments, missing a chance to follow up and risk losing customers. That's why in future work, we suggest focusing on improving precision. This ensures that everyone marked as satisfied by the model truly is, which making our predictions more reliable and more valuable to the business.
Hi, I'm Goyan. So in this part, we'll be talking about the performance important analysis. This analysis framework is adapted by a study we found on the Journal of Air Transport Management, which is based on the scoring variables collected from questionnaires and then using these kind of graph to evaluate both receipt performance and contribution to overall satisfaction. So here you can see the plot we draw based on the all passengers data. We believe that the service gap, which is very important but performing not very well, is the most important part we should pay attention to. For example, we can see the in-flight Wi-Fi service and the departure arrival time convenience is very urgent to improve. Notice that the flight distance scale is not a satisfaction factor. It is just that we find it very important, but usually not very far away in the distance. So in the next step, to give some personalized suggestions, we have clustered passengers into two groups. And in the third part, we took back the non-rating factors back to give a better passenger profile for people to understand what the two clusters are like. So using the elbow method, we decide that when k equals 2, we can see a very clear turning point. And also we have clustered it into a satisfaction rate of 17.28 and another of nearly 65% of satisfaction. So we believe that is both analytically valid and easy to interpret for business use. So when we look at our plotting map, we can see that for the not satisfying group of cleanness, food and drink, in-flight entertainment, seat comfort, all needs better improvement. While for people already satisfied to be more satisfied, we need to improve our in-flight Wi-Fi service, the departure arrival time convenience. So let's take a step back and look at what the clusters are like. We find that the not satisfied cluster are a younger cluster, which travels more on the economic class. And the satisfied cluster are a slightly older cluster, which travel more in a business class. Both clusters travel more on a business purpose, and the dissatisfied cluster, they travel on a lighter, not very far distance, but a satisfied cluster, we often witness them on a long flying distance trip. So also we can see that there are some improvements. For example, when departure delay, arrival delay are less, maybe the cluster will be more satisfied. So this is our performance and importance analysis, and that's my part. Thank you very much.
Now let's look at how each model translates into real business impact. First, in our logistic regression model, simply put, the higher the number, the larger the impact of this service feature on passengers' positive emotions. Based on this, logistic regression can accurately identify the key service attributes that can best drive satisfaction improvement and where leadership allocate resources, helping them prioritize resources to invest in improvements that can be best drive change. Second, moving on to random forest. This ensemble approach not only raises our predictive accuracy, but also ranks this feature by its importance in the model. These importance scores become a roadmap for setting precise service upgrade plans, helping us address areas most likely to cause customer loss. Third, Exit Boost allow us to quickly identify less obvious pain points and develop differentiated services in highly competitive airline markets, providing fast decision-making and make us ahead of emergencies. Therefore, our random forest and Exit Boost models divided the groups of satisfied and dissatisfied pure travelers by measuring feature importance. Our tree-based model also revealed strong interactive effect. Our tree-based model also revealed strong interactive effects. For example, seat upgrade and network enhancement benefits more than the sum of their parts. In addition, from the perspective of service quality theory, we found that several of indicators in the model that most related to satisfaction can be mapped to classic several dimensions. Furthermore, literature research shows that business and economy passengers prioritize different aspects of these dimensions. Finally, our Exit Boost model has high accuracy and low false positive rates, which means we can trust its prediction when predicting satisfaction trend and making budget allocation decisions. The revenue management can assign cabin promotions or service packages to passengers whose prediction satisfaction is below the limit, thereby minimizing customer loss and maximizing lifetime value. In this way, our feature importance analysis statistics quantify the business levers that improve passenger satisfaction, loyalty, and profitability. And this insight creates 4 business levers: operational efficiency, ancillary revenue, retention rate, and segmented value added.
Now, I will provide recommendations based on the data and model result. Firstly, from the perspective of data collection, most airlines widely use NPS, CSAT, and CES. Although these indicators provide insight into customer experience, they often overlook the depth of emotions and the context. To address this issue, we can combine traditional questionnaires with natural language processing. Passengers rate services such as check-in speed or seat comfort, where NLP analyzes open feedback to detect the emotional and service blind spots. This integration improves the accuracy of our model and reflects the real passenger experience. Besides, the dimensions of data analysis can be divided according to customer journey locations. For example, boarding speed and food quality can affect the on-board satisfaction. This can help airlines currently identify weak links and facilitate the development of phased optimization measures. Improving the service connections between links can also enhance the overall customer experience. In addition, different customer groups have different needs. Business travelers value efficiency and Wi-Fi, while leisure travelers prioritize comfort and entertainment. Understanding these differences enables airlines to provide more personalized and targeted services. From a business perspective, firstly, by improving mobile applications and websites and adopting real-time feedback systems to monitor service quality. Secondly, the seat comfort of medium to long flights can be improved. Thirdly, improve the in-flight experience by enhancing dining quality, providing stable Wi-Fi, and so on. Fourthly, strengthen artificial support for elderly travelers and improve accessibility through green channels and assistance. Finally, improve user loyalty through better training programs and personalized reward system based on customers' data. In short, improving customer satisfaction is not only a service goal, but also a strategic approach to enhancing the competitiveness, brand loyalty, and long-term profitability of airlines. We should attach great importance to the feedback given by customers and use this data to improve our service level. And this is our reference list. The above is our group's presentation. Thank you for listening.